Okay. So we start the next lecture. So before starting the lecture, I'll just introduce the next speaker. So we have Professor Manish Kumar Goel sir. So Professor Goel sir is currently working as a chair professor BIS standardization in the Department of Civil Engineering at IIT Indore. He has earned his BTech degree from NIT Warangal, MTech and doctoral degree from IIT Roorkee. He has ranked in top 2% scientist in list prepared by Stanford University in 2020, 21, 22 and 23. He has been awarded the JSPS Fellow, Commonwealth Fellow, Indo-US Wari Fellow, Inspire Fellow, Professor S.N. Gupta Memorial Lecture Award, Best Researcher of the Year 2020, Professor R.J. Garde Research Award, IEI Young Engineers Award, BRNS Young Scientist Research Grant, Young Alumni Professional Achievement Award, NIT Warangal, and several others. His research interest includes impact of climate change on water sources, statistical downscaling, hydrology and glaciology, crop modeling, soil carbon sequestration, data mining, etc. He has published more than 70 papers in prestigious scientific publications focusing on climate change, hydrology, glaciology, and etc. across Indian river basins. Might be more than that papers. He is currently supervising 3 external funded research projects and 13 complete projects as PI and co-PI. Maybe I am not updated with other projects, sir.
Chalo, thank you, Vikas. Thank you. I think we can start now.
Yes, sir. Yes, sir. Thank you so much, sir, for coming. Yes, sir. You can share the screen, sir.
Okay. Can you see the screen now?
Yes, sir. It is visible. Sir.
Okay. So, good morning. Yeah. So, good morning, everyone. And thank you, Dr. Vikas Punia, for inviting me in this Gyan course. So, today we will talk about the Ramsar wetlands and how these wetlands are across the India and what kind of risk they have. So you all are in the Bhopal, perhaps offline. You must have seen the Bada Talab. Bada Talab is considered as one of the wetlands or Ramsar wetlands in Bhopal, in Madhya Pradesh, India. So like this, we have more than 80 wetlands or 80 Ramsar sites across the India. And in the last 5 years, there is a sharp increase in the Ramsar wetland across the India because Government of India has done a lot of work in order to identify these wetlands and then designated them as a Ramsar wetlands. So in Madhya Pradesh, we have 4 wetlands, and in Indore, we have 2 wetlands, Yaswant Sagar and Sirpur. They are considered as a Ramsar wetlands. And what we are interested today, what we will talk today, we will try to identify that these wetlands, which are the basically capture the water in terms of groundwater, in terms of surface water for drought conditions as well as the flood conditions, and they help the urban agglomerations, urban cities, in order to extract the water in case required. Like in Indore, water is being taken from Yaswant Sagar as well as Sirpur whenever is required. So these wetlands, what kind of risk is there in the future, and in terms of climate change, or in terms of climate change, in terms of global warming, because we have seen across the India, across the world, the temperatures are increasing. Once the temperatures are increasing because of increasing the greenhouse gas emissions, and these increase in the greenhouse gas emissions is attributed to various parts or various regions, like increase in the industrializations, because in the last 2 decades or last 3 decades, India has grown rapidly with rate of 8% to 10% GDP per annum. So with this, a huge industrialization has been happened, deforestation, urbanizations, lots of construction activities, vehicular emissions. So many vehicles are on the roads. So all these has been contributed in the increase in the greenhouse gas emissions. And because of deforestation and urbanization, there is a land use and land cover change at many places. And all these things are contributing to increase in the greenhouse gas emissions, and then it is turning to the increase in the temperature. Once it increases the temperature, it impacts our hydrological cycle. Because once there is an increase in the temperature, it will intensify the hydrological cycles, and there is changes in the rainfall patterns. And once there is changes in the rainfall patterns,
sir,
yeah.
I think slides are not moving. I think you.
I'm on the first slide only.
Okay, sir. Thank you. Okay.
Okay. I'm on the first slide only. So I'm trying to create a base so that we can understand what we are going to talk in next 1 hour or next 1.5 hours. So once there is an increase in the temperature, there is an intensification of the hydrological cycle, and then once this intensification of hydrological cycles will occur, so various kind of rainfall spells will be there. There may be extreme heavy rainfalls, or there is no rainfall. So how these extreme heavy rainfalls will impact the wetlands? What kind of their stamina is there to absorb or to take that water? How these wetlands will behave under the various climate change scenarios or various telecorrections. Like you have heard a terms called El Nina or La Nina or ENSO, El Nino Southern Oscillations. How these wetlands will behave in the next 10 years, 20 years, 30 years, 50 years. For the rest of our life, how they will behave and how their inundation patterns will be there for next 50 years for various return level periods. So that we are trying to understand, because these wetlands are kind of lungs for Mother Earth. How these wetlands will behave. You can see on this motivation on this slide that healthy wetlands are vital for sustainable cities. There is some kind of a study where they say that these healthy wetlands are very essential for sustainable cities. And as of now, we are working on the Sustainable Development Goals, SDGs. These SDGs have been started in 2015, and now we are on 2025. So almost 10 years are done. 60% time has already passed. In next 5 years, what kind of SDGs we can achieve? So healthy wetlands are essential for sustainable cities. East of EM bypass, rainwater reclaims the former wetlands in Kolkata. And in the Bhopal, you can see overflowing Bhopal's upper lake floods Chirayu COVID Center. If you go from Indore to Bhopal, you will find once you enter the Bhopal, in the left-hand side, there is Chirayu Hospital. And in 2020, there is a huge rainfall. And because of these extreme rainfall events, there is an overflow of these Ramsar wetland, Bada Talab. And this Bhoj wetlands, the water has gone into one of the famous hospital in Bhopal. So these are the few news headlines that has come into the newspaper. In addition to that, if you remember that we have a Chennai flash flood in 2015, and in the Chennai flash flood, that has demonstrated how they have destroyed the wetlands, Pallikarnai marsh wetlands, and whole water has come into the city, and there is a human loss of more than 421 lives, besides destroying the flora and fauna, infrastructure, property, farmlands. So this is one of the impact of extreme events on these wetlands. So this Pallikarnai marsh wetland has increased the high rainfall intensity events and led to the extreme weather events and flood in 2015. There is a cyclone Barda and then drought in 2017. All these things of flood, drought and cyclones are keep occurring over these wetlands. Another examples I will give you in the northeast part of India, Guwahati. In Guwahati, we have a wetland called Deepor Bill. In the Deepor Bill, it's a kind of freshwater lake wetlands. It will cause frequent flash floods because Guwahati city has been urbanized so much that they are trying to encroach the area of these Deepor lakes. And then the last 2 weeks, majority of the city that has been built because of increase in the population from various places, and because of this, there is a frequent urban flash floods are occurring there. Another examples I will give you the Hirakud Reservoir, which is located in Odisha. And during the monsoon of 2020, they have witnessed the outbreaks of heavy rainfalls, and these heavy rainfalls have led to the floods. And these floods have caused the severe damage to the service road on embankments, lift irrigation ponds, and field channels. So here I give you the 3 examples of Chennai, Guwahati, and Hirakud Reservoir. So you can see the impact of these extreme events are happening in terms of homes, property, farmlands, lift irrigation pond, field channels, embankments. It means that these of the events are very disastrous. So as a hydrologist or as a hydroclimatologist, we need to understand the frequency, intensity of these severe events on these wetlands in order to survive for next 50 years, next 100 years, or next 500 years. what kind of events will occur in the future, what kind of measurable action points we can understand or we can take out of these extreme events. So that's one of the focus of this study. Okay, so what we have done, we try to identify the research gaps, and based on that we try to identify the objectives. First of all, there is an absence of any study of flood-induced heavy rainfall over the coastal wetlands of India. In this, the first part of the presentation, I will talk about the coastal wetlands, which are more vulnerable to all these kind of things. So, in the coastal wetlands of India, is there any flood-induced heavy rainfall? So, there is no systematic study has been done so far in order to investigate the flood-induced heavy rainfall over the coastal wetlands of India. Because if you see, in the coastal area, we have more than 7,500 kilometer length of coastal line, and along this coastal line there are so many wetlands. So what is happening to these wetlands? So what we have done, we try to investigate the uncertainties in terms of extreme rainfall of return levels using extreme precipitation indices. What is the meaning of return level? That we all understand. I'll not go into the details. We all study in hydrology. But using the extreme rainfall indices. So what kind of extreme rainfall indices are there? Whether how much rainfall is there, 1 mm per day, 10 mm per day, or any kind of cumulative bed days, all these kind of indices we have taken, and we try to understand in terms of return levels. Then the second research gap, we try to understand what kind of threats are there. It means which are the parameters of exposure, vulnerability, and in these coastal wetlands. So we try to relate these different parameters of threat and their interaction with the vulnerability and exposures. And in order to do so, we need to understand the risk label, because IPCC has given a formula, Intergovernmental Panel on Climate Change has given a formula of risk, that risk is equal to hazard, vulnerability, and exposure. So once we understand the risk level, based on these projected extreme events over the wetland, we try to understand using approach, and here we have approached the fuzzy logic approach. And once this has been done, we try to map, or we try to identify the areas which are highly vulnerable to the inundation or inundation mapping in terms of risk of flooding or overflowing. So we will try to do the inundation mappings of high risk level of coastal wetlands using an Google Earth engine. So based on this, using the Google Earth engine, we will try to understand the high risk level of coastal wetlands. Another thing that we try to understand is the monitoring change in the terms of wetland size. What kind of wetland size is there? Whether the 50 acres, 100 acres, 500 acres, 1,000 acres. Like if you know this Sundarban wetlands in West Bengal, it's one of the highest size wetlands in India, and Renuka Lake in Himachal Pradesh is one of the smallest size wetlands in India. So how these sizes are being changed over the years, what times of next 20 years, next 30 years, what kind of the trends are there in these wetland sizes because of these extreme events and their patterns. So this is the last one in terms of spatio-temporal changes. So these are the things which we will discuss one by one. As I told you that we are going to discuss about the coastal wetlands. Okay, so we will try to understand these coastal wetlands. If you see my mouse, these are the coastal wetlands we will try to understand. First one is Asatumari wetlands, which is an area of around more than 6,140 hectares. Then is the Bhitarnika and Chilka, you can see here. And then we have East Calcutta wetlands, Koleru Lake, Pallikarnai Marsh Reservoir Forest, Pichavaram mangroves, Point Kelly Marsh, Sundarban wetlands, Thampara lakes, Thane creeks, Vedantagal bird sanctuary, and 4 sides. We need to digitize the areas which are wet and which are dries. Then what we need to do? We need to understand the medians of the bed, you can see it here, and medians of the dries to calculate the threshold values. We need to compute some kind of threshold value. So medians of dry, medians of wet. And then based on this, we will identify the inundation maps. So where the medians are more than wets, we will identify the pixels greater than the thresholds or less than the threshold. We will take them in dry and wet and we'll compute these. So 0 we have taken for dry pixels. 1 we have taken for inundated pixels. So inundated pixels means water is there. Okay, the pixels having the SWIR values less than or equal to the SWIR threshold are classified as inundated, while pixels having the SWIR values larger than or equal to SWIR threshold are classified as dry. So that's how we have taken it, and this is the complete methodology from importing, masking, filling the gaps, selecting the bands, creating the composites, filtering the ears with missing areas and not any bands, and digitization. Once that is done, we will have the inundation mapping. So this is the methodology for inundation mappings. So methodology is done. Now what are the results and discussions for events, different kind of wetland events? Non-stationarity for HRE for wetlands. So these are the wetlands, if you remember. All these wetlands we have put on x-axis. And this is the RX1, RLs, return levels. These are the return levels for 20 years and these are the return levels for 50 years. So this is the return level for 50 years and these are the return levels for 20 years. And here is the RX1 level from 0 to 800 mm, you can see. But we can identify here. If you see here, this Thane Creek for RX1, this Thane Creek had the highest RL. This is the highest RLs among all these wetlands, from Asthamudi to Bimbada Kool. This is the highest RX1, Thane 1. And this is followed by Koleru. This is the Koleru. This is about 800 and this is about 700. So this is the first results. What about the simple intensity? STI, Thane Creek had highest RLs. For this also the Thane Creek has highest RL, followed by East Calcutta wetlands. This is the East Calcutta wetlands for return level of 50 years. What about the RL10? R10 RLs, it means mm per day. Bemband Kool wetland has highest RL, followed by Astumadi wetlands. So this wetlands is the highest, followed by Astumadi. This for CWD, Point Calimar wetlands and the bird sanctuary have the highest RLs, followed by Thane Creeks. In terms of CWD, so this is the Point Calimar. This is the highest, and then you have this bird sanctuary and this Thane Creek for CWD. So what is this happening overall out of these all 4 HREs? Overall, when considering all the return periods, Thane Creek, everywhere you can see. Koleru Lake, Koleru Lake, Koleru Lake, Koleru Lake, and the Koleru Lake. East Calcutta wetlands, Mumbai wetlands, and Sundarban wetlands. They have highest return levels, RLs, among all these wetlands. And these finding is also consistent with the previous studies that has been carried out by other researchers in 2009, 2010, and 2021. So this is the first kind of results of HREs over the wetlands. Once we have these HREs, now what kind of risks are there? for these coastal wetlands using the fuzzy logic. Okay, this is the Thane Creek, and here all these wetlands are there that I have just explained. So this is the RX1 for 20 years, SDI for 20 years, return levels, R10 and CWD. And these data sets are from for 50 years return levels. You can see from the region of risk level high, medium, low and unlikely. So the overall risk level assessment revealed that wetlands such as Thane Creek, Koleru, Pallaikarni Marsh Reserve Forest and Thampara Lake are classified as high risk under both RL for our core indices. Okay, so Thane, Koleru, Pallaikarni Marsh and Thampara Lakes, these are considered as high risk for both RLs, 20 years return level period and 50-year return level period at our 4 indices. So the result indicates that 4 wetlands are classified as a high risk, 5 are classified as a medium risk and 2 are classified as a low risk. So if you remember, we have 11 wetlands. Out of 11, 4 plus 5 plus 2, it means high, medium and low. 4 wetlands are high: Thane Creek, Koleru, Pallaikarni and Thampara. Okay, once we have understood the risk category, let us come to the inundation patterns. What kind of inundation patterns are there in these coastal wetlands? Okay, this is the Thane Creek. Thane Creek, if you see, this wetland has an area of around, let's say in terms of square kilometer, 65 square kilometers is the area. Maximum inundated area is 40 and minimum is 14. How much area was inundated in 2020? And this is the area inundated in 2020. So let us say this portion, whole this area got inundated. So 80 to 100% of Thane Creeks. If I take this Chilka Lake, this whole area got inundated. So these are the various legends, less than 20%, 20 to 40%, 40 to 60, 60 to 80, and 80 to 100%. And these maps generally is talking about the average of last 30 years from 1991 to 2020 of various each pixels. And rest of the things also you can see the inundation patterns of all these wetlands. Okay, let us take one example of Thane Creeks in order to understand the impact assessments. There is one kind of a news study by 2050. Mumbai will see 25% increase in the flash flood intensity. So let's try to understand this Thane Creek in Mumbai. This figure represents a visual presentation of the drainage. You can see the drainage line, drainage stream networks and topographical features. Flood and impact surrounding habitat and infrastructure due to extreme rainfalls. You have roads and railways, you have human settlement here, you have encroachment and you have an international airport here. So this Thane Creek is susceptible to the influence of running water from the flood drains and river beds. So these flood drains and river beds. And the flooding of wetlands are further intensified by the urbanization process of Mumbai city having, including construction in low-lying areas, encroachment on the wetlands, ineffective storm water drainage systems. So these wetlands are facing challenges from 3 quarters. First of all, construction in the low-lying areas, encroachment of the wetlands, and ineffective drainage systems because of urbanization process continuously going on in the city. So you can see these stream networks, you can see international airport, encroachment in that area, roads and railways, human settlements, all these things for impact assessment as one example of Thane Creeks. So what are the key findings for this study? There is uncertainty of the extreme rainfall events over the coastal wetlands have a highest return level period of 50 years that we have considered here. Coastal wetlands, Thane Creek in Maharashtra are more vulnerable to the flash floods due to the heavy rains. Just I have shown you an example. As a result, understanding the impacts of HREs on coastal wetlands in India is essential to appraise the conservation attempts and to improve the projections of flood threats in future climate scenarios. And these findings are useful for the policymakers to assess the impacts and increase in the urbanization or increased area, and we need to understand the best management practices to how to manage the wetlands. Okay. In addition to this, why these coastal wetlands are at higher risk? There is one more thing, that sea level rise. You must have heard that there is a continuously sea level rise because of greenhouse gas emissions, climate change, which is in turning the melting of the ice. So sea level rise is going on. So floods are more frequently and for the longer periods of the time. The frequency and the intensity of the storm surges and the tidal floods also increases. Storms and hurricanes, storm surge, high winds, and heavy rainfall associated with these events can cause flooding. Another thing is the erosion. As the coastal wetland erodes, the capacity to absorb and store water decreases. Because once you have erosion, it have lesser capacity to absorb and store the water. In addition to that, there is a lack of maintenance because you have sedimentation, you have debris, it can clog the waterways and drainage systems if you don't maintain them. So, sea level rise, storms and hurricane, erosion, lack of maintenance. What are the possible solutions for that? First possible solution that we can think of is restore the natural flow patterns. Restoring natural water flow patterns can help to manage flooding in wetlands by providing an appropriate balance of water inflow and outflow. Because of urbanization and because of the construction in many areas, we have blocked the natural water flow. Once we have blocked the natural water flow, it is creating the problems. There is imbalance for that. So we need to restore that. Reduce the upstream flooding by implementing measures such as retention ponds, natural filters, other green infrastructures. We need to reduce the amount and the velocity of water flowing into the wetlands. So once that is done, we need to reduce the upstream flooding. Construction of water control structures. We need to have some water, we need to have some kind of water balance flow. So once we have this construction of water control structures such as levees, dams, culverts, they can manage the amount of water flowing in and out of the wetlands. And then we need to develop some kind of a wetland monitoring systems. So in order to develop the monitoring systems, we need to put the steam rain gauges, and water level sensors at various levels and various depths, so that we can get a spatio-temporal idea of the early flooding, and that can trigger a early warning systems. So these are the few possible solutions to reduce the risk of coastal wetlands. And these are the few references that we have taken into the study. If you have a question, we can take the question now, or I can go to the part 2 of the presentation.
Do we have any questions? Anyone? No, sir. No one has any questions right now.
Okay. Then we'll go to the second part of arid wetlands. Okay. Okay, give me a moment. Okay. Okay, I can spend some time on this Ramsar wetlands. I hope many of you know. If you don't know, I'll spend few minutes on these Ramsar wetlands. Basically, Ramsar is nothing but one of the cities in Iran. So there's an agreement signed in 1971 on Ramsar conventions on these wetlands in order to protect and the responsible use of the wetland across the globe. So Ramsar Convention is nothing but the location that is located in one of the part or one of the city of the Iran. In 1971, they have done some kind of agreement to protect and responsible use of the wetlands. If we talk about the area, wetland contribute only 2.6% of the land area, but they play very important role in hydrology and the source of OC, organic carbon, over 20% of the globes. These wetlands are significantly habitat for vital flora and fauna, aesthetic values, cultural values, contain biodiversity stocks with potentially great and pharmaceutical values. These wetlands are invaluable assets for human life with benefits ranging from availability of rare varieties of herbs and plants of commercial and medicinal importance to a great source of the water. So vital flora and fauna, medicinal values, invaluable assets. And now these wetlands are projected to have lost and shrunk over several decades. That's what people are talking about. They are losing the areas. Once they are losing the area, they are threatening the important ecosystems of water refinement, controlled flooding, protection of biodiversity, and supply of the food. Okay, and then these wetlands are vital to address the 17 Sustainable Development Goals of United Nations, which are related to climate change, hunger, health, energy consumptions, and poverty. So, in order to do so, there are four strategic Ramsar plans, 2016 to 2024. There they have taken these four goals, addressing the drivers of the wetland loss and degradation, effectively conserving and managing the Ramsar site networks, wisely using the all wetlands, and enhancing the implementations. And how they are doing it? Because in the Ramsar conventions of this fourth strategic plan, they have these four overarching goals and 19 specific targets. You can see from T1 to T4, T5 to T7, T8 to T13, and T14 to T19. So these 19 targets, specific targets to achieve these SDGs. And in this context of 19 targets, India's ecosystems or India's wetlands, they are most exposed to the climate change projections of temperature rise, changing rainfall patterns, and greater risk of heavy rainfall. So what are the sustainability of Ramsar wetlands in India? That is very important aspect, and coastal wetlands we have just covered. So once we have covered the coastal wetlands, what about the arid wetlands? And the arid wetlands, we have taken the 17 sites. As per Köppen Geiger climate classifications, these areas are arid, desert, and hot. You can see. And these areas are arid, steppy, and hot. Where my mouse, you can see the cursor is there. And these are the site ID as per Ramsar conventions. So you can see 230, site ID number 230. This is Kebladev National Park. Area is 2,873 kilometers. So 230 is this one. So 7,830 kilometers. And you can see other these wetlands based on this Kebladev, Harike, Sambar. Sambar is this one, 464. Nanji, Nal Sarovar. Nal Sarovar is this one, 2078. Bees Convention, 2408. Vyas Convention. Sursai, Saman, Sursarovar. Sursarovar is this one. Sultanpur National Park. Thol Lake, Vindaj Lake, Kejadia, Rangatitu, Balod, Kanjarikulam, and Chitragudi Bird Sanctuary, 2491. 2491. Here are these all 17 Ramsar wetland across these arid regions, and they are located in different parts of India. You can see all across the India with different kinds of color. We have put Copenhagen climate classifications here, and whichever part they lie, you can understand that we have taken only these arid wetlands. Okay. So to investigate the non-stationarity of heavy rainfall events in terms of return levels over wetlands and arid regions in India. So whatever we have understood till now for coastal wetland, let us try to understand over the arid wetlands and the non-stationarity. So I hope we all understand the concept of non-stationarity. If we don't understand, I can explain in a minute. Non-stationarity is nothing but a, over a period of time, if the statistical properties, it means either mean, variance, if they vary over a period of time of a given parameters or given variables time series, then we will say it's a non-stationarity. It means whatever time series we have or whatever we have the period of for which the behavior of the data is not does not remain constant. It means the behavior of the data will be keep changing. Once it's keep changing, I'll say it's non-stationarity. And in this analysis, we have taken different kind of telecorrections like El Nino Southern Oscillations, Indian Ocean Dipole, Atlantic Multi-Decade Oscillations, and others. We need to understand here whether these return levels and the variability of extreme precipitation has any kind of relation with these indices. Okay, so let us try to understand the methodology. IMD data has been taken from 1951 to 2013 with all these four parameters that I have just explained to you. R1 in terms of mm, STI intensity mm per day, R10 10 mm precipitation in a day, and cumulative bed days. And then we have also taken these teleconnections of ENSO, IOD, and AMO, El Nino Southern Oscillation, Indian Ocean Dipoles, Atlantic Multi-Decade Oscillations. And based on these three telecorrections or climate indices, we have created 56 linear combinations of shape and location parameters. Once we have done it, we have a stationarity and non-stationarity of GEV models, generalized extreme value distribution models. And then we try to understand which is kind of a very good or best covariate combinations in terms of likelihood ratio test. And then we have developed some kind of emission frameworks and then the return levels of various days. Okay, so I'll not explain this slide once again. We have already explained this slide. The same data sets has been taken for arid rainfall regions. Okay, coming to the non-stationarity of extreme precipitation indices in terms of arid region. So these are the names of various wetlands of arid region. So for RX1, if you find out that Nal Sarovar wetland showed highest RL followed by Khijadia Wildlife Sanctuary. You can see my cursor. This is the Nal Sarovar wetlands, followed by Khijadia. So this is Nal Sarovar, this is Khijadia. So this has shown highest return levels. And here we have taken the return levels of 10 years, 20 years, 50 years, and 100 years. And in terms of SDI, Khijadia has shown highest RL. This is the Khijadia. This has shown highest RL. For R10, it's Chitrangudi, followed by Khijadia Wildlife. And for cumulative bed days, it's Ranganathu 2 bird sanctuary in terms of this Ranganathu cumulative bed days return levels. And these return levels are 10 years, 20 years, 50 years, and 100 years. So in overall, what's happening? Khijadia Wildlife Sanctuary, Ranganathu Bird Sanctuary, Sarsai Nabar Jheels, Nal Sarovar, and Thul Lake. They are the top 5 wetlands which have highest RLs across all these return periods. So what is this says? That these findings of several arid regions are significantly influenced by the global climate oscillations, with projected intensifying return levels of extreme rainfall as well as return periods. And the second thing, we have done the ranking with help of fuzzy logic. So in terms of ranking, once we have done for the fuzzy logic, the TRIS is nothing but hazard, vulnerability, and exposures. And the fuzzy parameters we have done for very high, high, moderate, low, and likely. Okay, this is the same chart that we have used. 0 we have given unlikely, risk rank 2, low, moderate, high, and very high. And this is the hazard parameters, vulnerability parameters, exposure parameters. 10 years of RL frequency, 20 years of RL flood frequency, 50 years of RL frequency, and 100 years of RL frequency. Vulnerability parameters, supporting services, human settlement, natural systems and water regulation, and annual rainfall days. In terms of exposure, you have crisis ecosystems and observed species. The resolutions are in various forms, vector files or various resolutions. These are the sources and these are data sets. Okay, coming to the vulnerability parameters. So these are the 4 parameters you can see here. All 4 parameters in terms of supporting services, human settlements, natural systems, and annual rainfall days. And out of annual rainfall days, let's say take annual rainfall days, it means the number of days in a year which a measurable rainfall occurs in a specific wetlands. So measurable rainfall is nothing but 1 mm. So you can identify the number of rain days: 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 75. So in these part little bit, some wetlands here you will find 50 to 70 days. All these wetlands here, this is 30 to 20 days, this is 20 to 30 days. So this kind of vulnerabilities are existing in these wetlands. In terms of exposure parameters, it means you have a crisis ecosystems. Crisis ecosystems, once we say whether you have a vulnerable space, vulnerable things, endangered things, or critical things, or the combination of these. And observed species groups, you have various kind of things: birds, fish, fungi, mammals, plants, reptiles. So all kind of things of exposure parameters as well as observed species in terms of exposed parameters for all these arid wetlands. Now let us come to the risk, how we compute the risk and how we can define the ranks for all these wetlands. Okay, so in this risk rank of wetlands across the arid region, few are unlikely, there is no risk at all, few are low, and few are moderate. It means there is no wetlands which has a high risk or very high risk. So overall risk rank assessment indicates that Sarsai Nalwar Jheel, Byask Convention Center, Chitragudi Bird Sanctuary, Kanjikulam Bird Sanctuary, Rangnathu 2 Bird Sanctuary, and Saman Bird Sanctuary, they are at moderate risk. Few are lower risk. And 5 wetlands, they have no risk at all. So what we have understood out of these wetlands, 17 wetlands, that these wetlands, some wetlands requires moderate risks and some wetland doesn't require much attention. So this is a kind of valuable insights for policymakers, researchers, conservation efforts, for enabling the development for effective strategies for wetland management, disaster mitigation, and climate adaptations. Okay, once we have done, we try to understand what kind of future challenges in terms of trend analysis is there. So for the trend analysis, we have taken the different kind of CMIP6 models for which the resolution is around 0.25 degree by 0.25 degree. These are the model names. This is the resolutions, this is the country, and this is the institute. For future data, AWS S3 Explorer, you can get the future data. Historical temperatures, IMD. Historical precipitations, IMD. Once you have future data from global climate models, you have historical data from IMD. We do the trend analysis using Mendenhall trend test, and we try to identify the patterns, whether it's rising, falling, cyclic, long-term movements, short-term movements, or different kind of steps. So you can see the average precipitation in all these arid wetlands. This is the average temperature. So average precipitation in terms of Chitragudi bird sanctuary, Kanjikulam bird sanctuary, Kanjli Ranganathi 2 bird sanctuary is greater than 700 mm, while Samar Lake, Bindwas with less than 500 mm, other wetland they have in terms of 500 to 700 mm precipitations. What kind of average temperature is there? In few wetland, Nal Sarovar and Thol, you have a 33-degree temperature, and other is less than the 33 temperatures. Okay. Now, what we have tried to identify based on two scenarios: SSP, socioeconomic pathways of 245, and shared socioeconomic pathways of 585. Whether these average precipitations are at what range? So average precipitations in Ranganath 32 is close to 500 mm, and Samar Lake is close to 250 mm, and most of the wetlands is close to 300 to 400 mm. And average temperature for Nal Sarovar and Thol Lake is about greater than 36, and average temperature of Ranganath 32, Kanjil, and Bias Conservation Reserve Forest is about 32 degrees Celsius. So this is the temperature range and precipitation range for various scenarios, shared socio-economic pathway scenarios of 245 as well as 585. So what kind of trends are there? Whether they are increasing, decreasing? Let us see it here. Okay. So historical precipitation trends in terms of historical temperature trends. In few of these wetlands, like you can say, this is increasing here, and this is decreasing in these two wetlands. In terms of temperature, there is no significantly decreasing, but there is significantly increasing on three wetlands, one wetlands. So historical temperature is either increasing or significantly increasing in most of these wetlands. What about the future? SSP 245 in terms of precipitation and temperature. So precipitation you can see in all these wetlands significantly increasing. Also the temperature is significantly increasing. In case of temperature, all wetlands have significantly increasing. What about the next scenario? 585. They are increasing significantly. They are increasing significantly in terms of precipitation, in terms of temperature trends. Okay. Next thing, what we can do once we understand the temperature and precipitation trends are increasing in these wetlands, so can we use the satellite images for induced flow map to validate the risk, flood risk output? So what we can do for that, we have developed a very simple methodology in terms of we can collect the satellite images. We need to pre-process the satellite data. Then we need to extract the flooded areas and flow patterns. Once we do, we will obtain the flood risk model output, and then we have to be validate, and then we refine and improve the flood models. So based on that, we can develop some kind of a flood mapping maps or flood models based on the satellite data. So what we have done, we try to understand where these flood events has occurred on these wetlands. Like you can see the serial number 1, Kebladev National Park, Bharatpur in Rajasthan. On 15th September 2024, there is a flood event, and this we got the information from internet news. Like Sambar Lake in again Rajasthan, 8 September 2024 and 2019, there is a flood events. Nal Sarovar, there is a flood events. Byas, there is a flood events. So we try to understand these flood events, and once we try to understand these flood events, we try to map them. If you see, this is the Kebladev map. In 2024, September 2024 and October 2024. So Kebladev, you can see in September 2024, here is only you can see the water. And October 2024, you can see the maximum area got flooded and inundated. So you can see 15th September, there was a flood. And after the flood, there was only small water, and then it got flooded. Similarly for Sambar Lake in September and October. September there is a water here, and October also this has been increased. Sambar also you can see it here, September 2024 and 19. And this picture is September 2024 and then for October. Likewise, what we have done, we have taken all these wetlands and we try to identify whether the flood that has occurred as per the local newspaper, local media can we capture that flood in terms of satellite images. So these are the flooded areas where we have taken this. You can see for Chitrangudi in month of June and then in month of July. This is the month of June picture. This is the month of July picture. This is Kanjirakulam. In the Kanjirakulam, you can see there is no water absolutely at all, and there is another water. And here you can see we have taken buffer area because the size of the arid wetland is quite less, so we have taken the buffer area. This is for Byas River Basin. This is for Kanjil. Another, this is for Rangatittu. Rangatittu you can see September and then the October. Belod. Another is Bindabas, Tarsaibal Jheel, Surjeel, Kijadia. Kijadia you can see here there is only small water, and then the water has come up in many areas. Thulke Lakes, Harike Lakes, Nal Sarovar Lakes. So what are the final conclusions? These wetlands can absorb the higher amount of water in terms of Sambar Sarovar, Kebladev, Byas conservation. In arid regions, flood are beneficial than the disasters. This is a very important conclusion. Because flood are sometimes seen as devastating, but they are vital for ecological roles, including redistribution of nutrients, recharging the groundwaters, and preserving the hills, preserving the health of the wetlands. It is also found that more floods are caused by small frequency of global factors such as ENSO, IOD, and AMO, not seasonal precipitation and temperatures. So these are the few references here for the arid wetlands. With this, if there is a question, we can take it, or I'll give you the one of the demo of Indore wetlands.
So there was one question from your previous presentation. Do you want to ask?
Yes, please.
So how do you validate the inundation area of a wetland in your study?
Yeah, inundation areas. So we take the satellite images.
So
Let's
sir,
say-
on the particular day, how
Yeah.
much of it?
particular day we have taken, then based on particular day, let's say there's a rainfall from July to September in a year. On any rainfall, on any rainy day, we will take that image of the day. We will try to identify how many pixels have more than threshold SWIR, because that threshold is based on either 0.5 degree by 0.5 degree, half a degree by half a degree, 30 meter by 30 meter, and each pixel we will identify. Once each pixel have the threshold of more than SWIR, based on that ratio, based on that equation, we will take that pixel as a bat area. And for each day we will do it, and for each month we will do it, for each season we will do it, and for each season means 1 year, and then we will do for 30 years, and then we will do the composite of all these, and based on composite we will make one single inundation map.
Thanks.
Okay, yeah.
Questions? Any questions, anyone? No, sir. No one has any questions at the moment. You can.
I'll take last one. Indoor wetlands. I hope you can see the presentation.
Yes, sir. It's visible.
Okay. So in Indore, we have two Ramsar sites. One is Yashwant Sagar Reservoir. Another is the Sirpur Wetlands. So this pictures we have taken on 30th November 2024. This picture we have taken for 7th of December 2024. So there are two pictures you can see here. 30th November 2024 for Yashwant Sagar, 7th of December for Yashwant Sagar. So after a week's this times. And if you can see these indices, high chlorophyll content, moderate chlorophyll content, low chlorophyll content, and the clear water. So total area of this wetland is around 800 hectares. High eutrophication area is around 123 hectares. So you can see the changes occurred in these areas. This area you see here, and then this area. So 1 week there is change. Similarly, if I go to Sirpur wetlands, this is the picture image of 30th November. This is the image for 7th of December. Total area is around 165 hectares. If you see in this area, and if you see in this area, there is change. It means eutrophications have been increased. Once the eutrophication have been increased, so let us go one by one. This is Yashwant Sagar. This is the picture of 30th November. This is the picture of 7th of December. So clear water is more, then the clear water has been reduced. Eutrophication level, whether low, medium, and high, low eutrophication level has been increased, moderate remains same, high remains lower. So it is observed that the entire sites with 17% of area has low eutrophications on 30th November, which is enhanced to 46% on the 1st of December. So there is a kind of increase. So this is the growing of the vegetable on dried land of Yashwant Sagar using insecticides, pesticides, fishing activities, illegal poaching of birds are affecting the ecosystems of these sites. So eutrophication area has been increased. Let us see the Sirpur. In the Sirpur, you can see the clear water is remain same for 30th November as well as the 7th of December. Low is also remain same. Moderate is okay, and then you can see the high. So it is observed that site has high eutrophication around 56%. On 1st of December with similar conditions on 30th November. So what is happening? Due to the discharge of the domestic wastewater into the Sirpur lake, the water quality of the lake are affected and the development of water hyacinth may be observed. So that kind of study is there for Sirpur wetlands. Another thing you can see, this is a Sirpur, whole Sirpur, and this is the Indore Dhar road. Here are the residential areas. Lower Sirpur Lake, there is under construction STP. This is the Upper Sirpur Lake, and this is Devi Ahilya Sarovar Udyan. So Lower Sirpur Lake is highly eutrophicated compared to Upper Sirpur Lake. This is less eutrophication. Here is the high eutrophication. So this is some kind of a water quality study of real time of these indoor lakes in terms of high chlorophyll content, moderate chlorophyll content, low fluoride content, and clear water in terms of NDCI. So this is a real kind of observation system that we are planning to develop. For every week, we will give the data so that wherever eutrophication is more, wherever there is a requirement of human action, that can be done. This will help the manpower, time, and energy. So that kind of work is still in the process. So with this, I will come to the end of the presentation. If you have any question, you can ask out of all these three presentations on the wetlands.
Thank you, sir.
Thank you.
Any questions?
Sir, I have a question.
Yeah.
How can we conserve Bhojtal wetland of Bhopal? Because the overall surface area of Upper Lake is also decreasing day by day.
I think that's a very good question, and that's very pertinent as on today. Bhoj wetland, I have shown in one of my presentation. In the first presentation, I have shown that there was a huge rainfall in 2020, in August 2020. Water has come up and it has inundated the Indore Bhopal road as well as the Chirayu hospital. So first problem is coming the encroachment of these wetlands. Because of human settlement and many other areas, the encroachment has been increased. Second thing is coming the agriculture activities, they are going on in these wetlands. So agriculture activities, farmlands have been created and these wetlands areas has been increased, wetland areas has been reduced or even shrinkage. So you have urbanization, you have encroachment, you have a farmlands, and there's huge kind of sedimentation is coming. The sedimentation has to be reduced in order to increase the base flow, in order to increase the overall process or overall profile of the wetlands. So these are the few measures we need to take it up in order to maintain the same area or in order to increase the area.
Any other questions, please? Okay, sir. So thank you so much, sir.
Thank you, Vikas. Thank you so much.
Sorry. Thank you so much for giving your time from the busy schedule, and I think they have got insights on the wetlands, so they may start their work on the wetlands also. Thank you so much, sir, for your time, sir.
Thank you so much. Thank you, everybody.
Thank you.